Hi everyone. Notes 5.6 are on solving linear trigonometric equations. So we're going to apply everything that we've learned so far this unit to actually solving linear equations. It shouldn't be all that new to you when we actually end up doing this. The quadratic ones will be a little bit newer, but this should be kind of familiar to you guys. So question number 1 says to solve the equation 2 sine x plus 1 equals 0. For 0 is less than or equal to x is less than or equal to 2 pi. So if you guys could just change this to x so we have a consistent variable, that'd be excellent. And let's go ahead and write out how to solve this, okay? So 2 sine x plus 1 equals 0. I'm going to try to isolate sine of x, just like we've already done on previous questions. So I'm going to say 2 sine of x is equal to -1. Okay, then I'm going to divide both sides by 2, and I get sine of x equals -1/2. Okay, now what I'm going to solve for first is I'm going to try to find my related acute angle, because once I find my related acute angle, I can use that to help me find where sine of x is -1/2. Okay, so for my related acute angle, that will happen when we have sine of x is +1/2, which means x is equal to the inverse sine of +1/2. Okay, so I'm going to take a look at my unit circle right here, and I'm going to see, I know that at pi/6 right here, the coordinate is √3/2, 1/2. So I know that sine is the y value, and I know the y value is 1/2. So I know that x, the angle that I'm looking for, the acute angle that I'm looking for, has to be pi/6. Okay? Now that I've done that, I need to take a look at the fact that I'm looking for sine of x equals -1/2. So using the cast rule, I know that sine is negative in quadrants 3 and 4. So I'm going to draw a picture. It's going to be a congruent triangle. So I'm going to draw a picture of the two triangles that do work with related angles of pi/6. My related acute angles inside of here are pi/6. So right here, I know that this full angle measurement right here in quadrant 3 is going to be pi plus another pi/6. Okay, so getting a common denominator, it's 6 pi/6 plus pi/6. So I know that the first answer that works is at 7 pi/6. Okay, and then in quadrant 4 right here, I know that it's all the way around here, so it's pi/6 shy of my 2 pi. So I know that in quadrant 4, it's going to be 2 pi minus pi/6, and I know that 2 pi is 12 pi/6 minus pi/6, so I end up getting 11 pi/6 right here. And those are my two answers. Those are what x is going to be. So my two solutions are 7 pi/6 and 11 pi/6 in this interval. Remember, if we have all real numbers for our interval, we'll have infinite solutions, and this would just be plus 2 pi n, and this would be plus 2 pi n because it's repeating every 2 pi. So now it says to verify the solutions using graphing technology. So we're going to go to Desmos right here, and we are going to type in the left side of our equation for our first y equals, our first function, and then we're going to type in y equals 0 for our second function and see where they intersect. Or we could just see where they intersect on where this graph intersects on the x-axis. But I want to restrict my domain from 0 to 2 pi right here, and then I'm going to say y equals 0, and then I'm going to go ahead and look at my answers, and my two answers occur at 7 pi/6 and at 11 pi/6. So my solutions for x right here are 7 pi/6 and 11 pi/6, and that is my final answer for question number 1. Okay, all right, so let's take a look at question number 2. Number 2 says to solve for theta, where 3 tan of theta plus 1 is equal to 2, and theta is between 0 and 360. So this time our answer is going to be in terms of degrees as opposed to having it in radians. Okay, so the first thing I'm going to do is I'm going to get rid of this 3 right here. So if I have 3 tan of theta plus 1 equals 2, I'm going to divide everything by 3. So I get tan of theta plus 1 is equal to 2/3. Okay, then I'm going to subtract the 1, and when I subtract the 1, 2/3 minus 1 is negative 1/3. Okay, so that means that theta is going to be equal to the inverse tangent of negative 1/3. But just like we did before, I'm going to try to find the acute related angle. Okay, and to find the acute related angle, we know that we're going to look for where theta is equal to tan of positive 1/3. When you do this in your calculator, please make sure that your calculator is in degrees when you're trying to solve this. So if you look right here, I am in degrees. So I'm going to take the inverse tangent of 1/3, and I end up getting about 18.4 degrees, and it says correct to 1 decimal place. So my related acute angle is 18.4 degrees. Okay, so again, just a reminder that this is the acute angle, not the actual solution. So then I'm going to go to my coordinate plane, and I'm going to use the cast rule. And if I look at the cast rule, I'm going to see where is tangent negative. So if the acute angle is 18.4 degrees, it means that our triangle for the acute angle is going to be in quadrant 1. But tangent is positive in this quadrant, so that doesn't make sense. So I need to find where tangent is negative. And I know tangent is negative in quadrants 2 and 4. So if I draw the congruent triangles right here, this is 18.4 degrees, and then this is also 18.4 degrees. So that makes theta equal to get to this angle right here, it's 18.4 degrees shy of 180 degrees. So I know that this is 180 minus 18.4 degrees. And for the other angle, I know it's all the way around here, so it's 18.4 degrees shy of 360 degrees. So I would do 360 minus 18.4 degrees. And when I figure out those values right here, I know that my two answers are 161.6 degrees and 341.6 degrees. And those are my two answers. Okay, so we can say it's 161.6 degrees, 341.6 degrees, and we have solved this question. Okay? Number 3, it says, today the high tide at Matthews Cove, New Brunswick is at midnight. The water level the water level at high tide is 7.5 meters. The depth d meters of the water in the cove at time t hours is modeled by the equation d of t is equal to 4 plus 3.5 cosine of pi over 6t. Nadine is planning a day trip to the cove tomorrow, but the water needs to be at least 2 meters deep for her to maneuver safely. To maneuver her sailboat safely. So at what times can Nadine safely sail into Matthews Cove? Okay, so clearly what we want to do is we want to plug 2 in for d of t. So we're going to say 2 equals 4 plus 3.5 times cosine of pi over 6 t. Okay, and we're going to isolate this cosine of pi over 6t. So I'm going to subtract the 2. So I get negative 2 equals 3.5 times cosine of pi over 6t. Okay, then I'm going to divide both sides by negative 3.5 right here. So I get negative 2 over 3.5 is equal to cosine of pi over 6t. All right, so now once I've done that, the next thing that I want to do is I want to find the related acute angle. So let's go ahead and find a related acute angle that's going to work for us here. Okay. So I'm going to take the inverse cosine of positive 2 over 3.5, and that's going to be my related acute angle A. So now when we do this, please make sure you are in radians this time. I'm going to take 2, divide it by 3.5, and then I'm going to take the inverse cosine of that value. And when I do that, I get about 0.96. Okay, so here I know that my related acute angle is about 0.96 radians. So looking at it in the unit circle right here, 0.96 radians is approximately somewhere around here. So this is the triangle that I get with my related acute angle of 0.96. Okay. But using the cast rule, we need cosine to be negative. So that means that we will have our resulting congruent triangles in quadrant 2 because cosine is negative there, and in quadrant 3 because cosine is negative there. And our related acute angles are still 0.96. So to find my two angles that actually work, the first angle would be pi minus 0.96. And the second angle would be pi plus 0.96. So that means that my two angles right here would be, the first angle would be 2.18 right here. And then the other angle that we have here would be pi plus 0.96, so 4.10. Okay, so we know that that's equal to pi over 6t. Because right here, to solve for this equation right here, we take the inverse cosine of negative 2 over 3.5, and that's going to equal this pi over 6t. So that's how we get these two answers right here. Okay? So now that I've done that, I'm going to isolate the t. So to get this t alone on this side right here, I would just multiply by the reciprocal, which is 6 over pi. So this means t is equal to 2.18 times 6 over pi. And we'll calculate what that is in a minute. And here we know that this means that t is equal to 4.10 times 6 over pi. Okay, and we'll calculate what that is in a minute as well. So let's go ahead and do that. So 6 over pi times 2.18, we end up getting 4.16. So here t is approximately equal to 4.16. And here we end up getting 6 over pi times 4.10. And we get here that t is approximately equal to 7.83. Okay, now that we've done that, we need to understand exactly what this pi over 6 is telling us right here. So if we know that k is equal to pi over 6, and we know that our period is equal to 2 pi over k, then we know that our period is equal to 2 pi over 6. Okay, which means that our period is equal to 2 pi times 6 over pi. So these pi's cancel. So our period is 12 hours. Okay, so this is going to repeat twice in one day because our period is 12 hours. Okay, so that means that we also can add 12 hours for the next cycle. Okay, so here when I add 12 hours right here, that means t is equal to approximately 16.16. And here when I add 12 hours onto here, I get that t is approximately equal to 19.83. Okay, so now let's just get a visual of what this will look like on Desmos. So if I were to look at it on Desmos, I've graphed out my graph right here, and I know it needs to intersect at y equals 2. And I'm looking at it just between 0 and 24 hours because we're looking at it in one day. And as we can see, all the intersection points that we got as our answer right here all work right here. Now, it's safe for her to use her sailboat if there's at least 2 meters of water. So anything above 2 meters will work. So we can see that from 12 o'clock until this 4 o'clock time, it's okay. And then from about almost 8 o'clock until this 16 o'clock time, we're okay as well. So, and then anytime after this about 20 o'clock right here. So let's convert all of these times into all of these numbers into actual times. So if you take a look right here, we have 4.16. We can see that this right here is 4, and then if I were to multiply 0.16 times 60 minutes, we can see that it's about 10 minutes. So 4:10 a.m. And then we can figure this one out right here. Well, it's 12 hours later, so it would have to be 4:10 p.m., but let's make sense of it. 16 o'clock is 4 hours after 12 o'clock. Add 4 hours onto that, and we figured out 0.16 is 10 minutes, okay? And then for this one right here, it's about 7, and then let's figure out 0.83 times 60 gives me about 50 minutes, so 7:50 a.m. And then this value right here is 12 hours later, so 7:50 p.m. So if we take a look at our Desmos graph, we can see from 12 a.m. to 4 a.m. she's okay. From 7:50 a.m. to 4:10 p.m. she's okay. And any time after 7:50 p.m. right here will work as well. Okay, so we can say therefore, now one last thing, since it's a day trip, we don't have to worry about anything before 4:10 a.m. and anything after 7:50 p.m. So we can say therefore she can maneuver safely between 7:50 a.m. and 4:10 p.m. And that's our answer to question number 3. And then question number 4, we're going to discuss together as a class next time I see you guys. So that's it. Let me know if you have any questions, and make sure you get some practice on a lot of this work so you can become fluent in all of this stuff. All right, have a great day. Bye.